Okay, here today in today's lesson we are going to learn about the exponential function. So here I have taken exponential function e to the power x. Okay, it is exponential function which is equal to y. If we sketch the graph y equal to e to the power x, it is always crossing from 1, right? So if we sketch, so it is going like this, and it is graph of y equal to e to the power x. What happens if y equal to e to the power minus x? Then its graph will be like this. Okay, it is reflection of red graph along y-axis. So this blue line is graph of y equal to e to the power minus x. Yeah, and this you can plot it by taking different values of x. Now, differentiation of e to the power x with respect to x. Okay, so it is called d over dx of e to the power x. It means differentiation of e to the power x with respect to x is always e to the power x. This you are going to learn in year 13. Okay, so gradient of e to the power x is e to the power x. What happens if some constant is there, like a is there, eax? So d over dx of e to the power ax, we can write down here, a comes forward, a e to the power ax. How it is happening, I can explain you, but this you will use it in year 13 when we are doing chain rule. Okay, but I can explain you, it is a good beginning. So how? I'm explaining how a is coming forward. So see, first of all, let y equal to e to the power ax. Okay, and we are learning how we got a e to the power ax. So see, suppose or let e to the power a to the power x as a u. Okay, so we have suppose as a u, and what we need to do, we need to differentiate with respect to x both side. So d over dx of e to the power ax, but our ax is u, so I have supposed this ax as a u. So let's put u here. So d over dx is e to the power u, right? Now there is a problem. What is the problem? Here is u, okay, and here is x. Okay, you can't differentiate u with respect to x. Yeah, u can be differentiated with respect to u, x can be differentiated with respect to x. Yeah, so we are stuck. So once we are stuck, what we need to do, we can introduce du here. So, and to make a balance, we can multiply by du and divide by du, right? So let's do it here. So, but I write down in this way, d over du is e to the power u. I have multiplied here in the denominator and multiplied here in the numerator, and this dx is already there. Okay, so if you see my green ink, so it was already there and it was already there. So you can see extra du and du is here, right? Is that fine? Any question? Why I did that? Because it is e to the power u. U can be differentiated with respect to u. Okay, Zani, okay? Listening? Zan, listening? Okay. Now, next one is, once you do that, so we know that d over dx of e to the power x is e to the power x. So d over du of e to the power u is e to the power u. So in this place, we can write down e to the power u, and du over dx is already here. Now, if you see here, it was ax as a u, right? Differentiate both sides with respect to x. So a is constant, so d over dx of x and d over dx of u. D over dx of x is how much? Guys, d over dx of x. Guys, d over dx of x. You have done differentiation, right? See your condition. D over dx of x to the power n is nxn minus 1. Yeah. So when it is only x, it means power is 1. So 1 is coming forward, 1x, 1 minus 1, 1 minus 1 is 0. So 1 x to the power 0 and x to the power 0 is 1. So we got d over dx of x is 1. So 1 times a, it is d over dx, that is a. Is that okay? Right? That's it. Job done. Now here d over dx is a. Put this d over dx a here. So it is a and it is e to the power u. This we can write down a, e, u is, put the value of this u back, u was ax. So see, we got a e to the power ax. So this was our formula, d over dx of e to the power ax is a e to the power ax. So here are 3 questions. Y equal to e to the power 2x. You need to sketch the graph. You can pause the video and try. Okay. Welcome back if you have tried. So y equal to e to the power 2x graph. So we know our base graph is e to the power x. This is y equal to e to the power x graph, right? So y equal to e to the power 2x graph will be little up. Okay, and then this blue line is going below red line. Okay, so this is graph of y equal to e to the power 2x. Now next is 10 e to the power minus x. So what we need to do, first we will sketch 10 e to the power minus x. Okay, so here y equal to e to the power minus x. So I'm sketching this first. Forget about 10. So this will be like this. Okay, so this is graph of y equal to e to the power minus x. Yeah. Okay, it is multiplied by 10. Multiplied by 10. So you must have done in GCSE. If it is you're multiplying by 10, then this is 1 point here. So it is crossing at point 10. So this graph is going up. Y coordinate will change and this will be graph of like this. Okay, so it should be 10 to the power, it is graph of 10 e to the power minus x, right? Okay. Now, if we are going for question number 3, okay, if you have any question, you can ask. Question number 3, first we are sketching this part, e to the power half x. So see, we'll do this in 3 parts. Okay, so this is e to the power half x. It is passing from 1 and graph will be like this. Okay, suppose this is e to the power half x. Now in the previous graph, like when we multiplied by 10, then it was passing from 10. Now it is multiplied by 4. Can you see here? It is multiplied by 4. So it will pass through 4, right? Is that okay? So it is passing. So it is 1 here. So what will be the coordinate here? Yeah, coordinate will be 4. Okay, so suppose this is 4. So graph will be like this. So this is 4 e to the power half x. Now 3 is adding here. So it means it is going 3 unit up, right? It means it is going 3 unit up. So in that case, what will happen? It will cross from 4 plus 3 is 7. So it is crossing from 7, right? So our 7 graph will be here. Here important thing is when it was crossing from 1, so this was asymptote, yeah, x-axis. Yeah, when it is crossing from 4, then 3 will be asymptote. When it is crossing from 4, then 3 will be asymptote, right? So in this case, when it is crossing from 7, okay, because it has gone 3 up. So 3 up, 3 up. So this 3 will be asymptote. So let me draw a line here for 7 line. Let me draw it here because there is not enough space. So if it is 7, so it will be going like this, and this point is 7, and this will be asymptote here 3, y equal to 3. Okay, and this is graph of y equal to 3 plus 4 e to the power half x. Okay, any question, guys? Now, as I told you differentiation, so you need to differentiate these question using this formula. D over dx of e to the power ax is this a. This a is coming forward here, right? So let's write down here a e to the power ax. This is formula which we have done it now. So if you see my yellow highlighter, this a is coming forward. Yeah. Okay. So using this formula, you need to do question number 1. If y equal to e to the power 6x, you need to differentiate it. If y equal to e to the power 3x plus e to the power 5x, you need to differentiate it. Third one is if it is e to the power x and here again e to the power x plus 1, you need to differentiate it. Pause the video and have a go. Y equal to e to the power 6x. So dy over dx and d over dx of e to the power 6x. So this 6 is coming forward and you can write down e to the power 6x y using this formula. Now here there are two parts, this one and this one. So first part you differentiate it. So I'm writing directly 3 is coming forward, 3 e to the power 3x. Here 5 is coming forward, 5 e to the power 5x. Is that okay? Using same formula. Here you need to multiply first. Y equal to e to the power x times e to the power x, and we know this rule of indices, a to the power m times a to the power n power adds. So e to the power x times e to the power x, x plus x becomes 2x. So this should be e to the power 2x, and e to the power x times 1 is, it should be e to the power x. Once we differentiate it, so you write down here dy over dx, here also you can write down dy over dx. So 2 is coming forward, so 2 e to the power 2x, and it should be e to the power x. Okay, check your working with my working, and if you have any question, Govind, you have question? Okay, so this should be your answer. Okay, so in next lesson we are going to learn exponential modeling.